Okay, stat students, we're going to go ahead and we're going to look at our last two graphs for quantitative data. Our first one is called a histogram. Histograms are really good for large sets of data and for data that does not repeat values. So on dot plots we have a lot of repeated values, and so we put the dots one on top of another, and that gives us our shape. But with histograms we don't. With histograms we take values and we place them in bins, which is really just a big interval of values. And so our bins could be numbers like from 4 to 5, 5 to 6, 6 to 7. And what's really important is that those bins have to be equal width. So you can't go 4 to 5, 5 to 6, 6 to 7, and then go 7 to 9. And then what we do is we have a bar that represents how many values that are in that interval. So if I have 3 values in here, 1, 2, 3, then I would have a bar that is 3 units tall. What we need to know is that when we're looking at a bin, so my bin from 4 to 5, the 4 is included in here, but the 5 is not. So it's all numbers up to 5. So 4.999999999. Anything up to 5, but not including 5. Where 5 is included is 5 is included in the next bin from the 5 to 6 region. And again, 6 is not included. 6 would be included in this bin. And so the way our graphs can look like would be like this. So I'd have a 4 and 5 and 6 and 7. And then I'd have a bar. So if it's 3 units tall, that's saying there's 3 numbers between 4 and 5. Or from 4 to 4.999999. And then if I had one at 1, then there's only one number between 5 and 6. And then like 2 numbers between that. And so that's how a histogram works. It looks like a bar graph, but the bars are right next to each other, and the bars really indicate how many numbers are within that bin range or that interval. Okay, so we're going to go ahead and actually create a histogram. So we have fat grams for McDonald's beef sandwiches listed all out in order for us to make life just a little bit easier. And we're going to create a histogram with bin widths of 5. So we kind of get a choice on our starting values. We could start at our lowest one, which is 9, or we could pick something that's a little bit easier to work with, like 5. So I'm going to go ahead and start with 5 because it just seems like an easier number to work with. And then my bins will go by 5s. So 5, 10, 15, 20, 25, 30. I don't know why my 5s aren't showing upright. Okay, then 35 and 40 and then 45. And so there's my number line to help create my histogram. And then I also have measures over here that tells me how many numbers. And so that's known as my frequency. How many values are in each, helps if I spell frequency right, are in each bin. So this means there's one number in each bin, 2, 3, 4, and 5. So now what we're going to do is we're going to go ahead and look at our list and figure out how many numbers do I have between 5 and 10. So between 5 and 10 I have one number, so then my bar goes one number high. And then I look at my next bin, 10 to 15. So from 10 to 15 I have one number. So my bar is one number high. And then I go to the next one, 15 to 20. So 15 to 20 looks like I have 3 numbers. So I go 3 boxes high. And then from 20 to 25 looks like I have 2 numbers. And then from 25 to 30, 1, 2, 3, 4. So 4 numbers. And then we've got from 30 to 35, which are no numbers. And then from 35 to 40, looks like we have 2 numbers. Now remember, the 40 is not included in there. The 40 is in the next bin. So there are really just 2 numbers in here. And then when I go to the 40 to 45 bin, now that 40 is included in there, because the 40 is that lower bound. And the lower bound's always included. And that's our histogram. And so then once we have a histogram, again, we're looking for the shape of our distribution. So we're looking at, if I kind of trace this and look at it, what's happening there. So is it symmetrical? Is it left skewed? Is it right skewed? What's really happening there? And this one is another one where you can kind of go both ways. You could justify that it's pretty symmetrical. We're out 4 on this side. We're out 3 on this side, which is pretty close to symmetrical. Or you could even say that we have more values on this side, less values on this side. But it's really kind of hard to tell. So as long as you can justify it, you can go with symmetrical, or you could go with the skewed. I'm going to go with symmetrical because it's just too close to really call. And I just feel more comfortable going with symmetrical when it's too close to call. And then when you're describing the distribution, you're not just describing the shape, you're also looking for your center. So I'm going to go ahead and go for my median. Which looks right about at 26, which makes sense because that's also our modal group. And if it's truly symmetrical, then we will actually find that our mean is also somewhere right around 26. And so we could go through and calculate that. And then don't forget, you're also looking at your spread. And don't just put down that your spread is something. Tell me how you're measuring that spread. So are you measuring the spread through range? Are you measuring the spread through IQR? Are you measuring your spread through standard deviation? But whatever one you're using to measure your spread, make sure you're stating what that is. Okay, the next one we're going to talk about is the modified box plot. The box plot is a graphical representation of your 5-number summary. And your 5-number summary is these values right here. It's our minimum, our first quartile, our median, our third quartile, and our max value. Now, a modified box plot will also show if and where there are outliers. So with a modified box plot, that may look like, okay, here's my minimum value, and then I draw a line, and then here's my first quartile, here's my median, here's my third quartile, and then I draw the box. And then I'm going to draw a line out, and then it's going to go towards my highest value that's not an outlier. So if this is my highest value that's not an outlier, and then I have 2 outliers, the graph's going to look like that. So my outliers actually become dots on there, so that way when you're analyzing it, you can look at the distribution as a whole, and you can look at the distribution by ignoring the outliers to see what kind of effect those outliers have on the distribution. And so this is what a modified box plot looks like. Now, our 2 box plots that we're doing today actually do not have outliers. So we don't have to worry about these extra dots over here that are outliers. So I'm going to go ahead and just grab these really quick, that graph, and we're just going to move that over there for right now. And we're going to go ahead and work on this. So we have males and females, and what we did is we asked them how many contacts do they have in their phone, how many numbers do they have programmed in their phone. And so, and then we have the numerical summary. So for males, we're going to go ahead and look at them first. So what we need to do is we need to look at, for males, our minimum value is 27, our highest value is 290. So we need some sort of a number line that's going to get us from 27 to 290. So I'm going to go ahead and start at 20. And then I kind of have an option. It doesn't look like my graph is big enough to actually go by 10s. Probably not even big enough to go by 20s. So I'm going to go by 30s or 40s. But since I like even numbers, I'm going to go by 40s. So this will be 60, 100, 140, 180, 220, 260, and then 300. Now, every time we're graphing, we're not just putting our numbers on the line. We're actually stating, what do these numbers represent? And this is contacts in phone. Always labeling our graph, our values, so that way we actually have a good graph set up for us. And it's just good habit to get into, because on your AP exam, you will get discounted if you don't label. So for males, we're going to go ahead and start with our minimum value at 27. So I'm going to go ahead and put a dot at approximately what I believe to be 27. And then I'm going to graph the first quartile, which is 64.5. So I'm going to go ahead and put the line there, and then I connect the dot to the line. So there's my minimum, my first quartile. Then I'm going to graph my median, which is right around 110. So I draw a line right there. And then I'm going to draw my third quartile, 167.5. So probably right around maybe here. And then I draw out the box. And so the idea is that everything inside this box is that IQR. It's that middle 50% of our data. So it gives you an idea of where that spread is. And then we go out to our max value, which is 290. So now when I'm looking at this box plot and we have to describe what's happening with our male phones, our male contacts, we'd want to look at the shape of this. So when we're looking at the shape of a box plot, what happens is our tail is actually really long and our peaks are really short. So right here, because this part of my box plot is long, that's really my tail. And since these are really short, these are where my peaks are. So it's a bunch of numbers all condensed in that little area. So this is definitely what we would call a right skewed distribution. Oops. Because our tail is to the right. And what's nice about this is it gives us our values. So we've got center, which is a median. Because in box plots we see that right away of about 110. We've got a spread of about 103. And that spread was measured by IQR. And then we'd check for outliers. Now I told you there was no outliers because I went ahead and checked in advance. But we've already talked about how to check for outliers. We do 1.5 our IQR, and we subtract it from our first quartile to find our lower bound, and we add that 1.5 IQR to our third quartile to find our upper bound. If we have any values outside of that, that would be considered an outlier. Okay, so now we're going to go ahead and look at the female contacts. So we're going to go ahead and graph that. And we're going to graph this on the same graph. And so this is what we would call parallel box plots or side-by-side box plots. So that way it makes it just easier to compare and analyze the two different distributions. So with females, our lowest value is 22. Our first quartile is 83. Our median is 129. Our third quartile is 180. And our max value is 218. So overall, when we're looking at this, we're starting to see a couple of other trends here. So it looks like our longest piece is over here, so that kind of looks like our tail. Our smallest piece is right there, that's probably our peak. So this is definitely a left skewed distribution. Our center is definitely higher. Our center is 129, which is almost 20 contacts higher. Now our spread is really similar. Our spread is really only 97. So it's got a similar spread to males when we're looking at just IQR. But when we start looking at these outer values, these tails right here, tails and tails, then we're getting bigger ranges. So our standard deviation for males is going to be higher, and we can see that right here. Standard deviation is higher because it takes those outer values, where IQR does not. And then there were no outliers. And again, I checked that beforehand. But you could do it just to double check. And so that's our box plots. So in class, we're probably going to be taking a look at some box plots. I'll be asking you about the shape, the center, comparing them, describing them, and maybe making some of your own. So we'll see you in class.